So we're getting started with Chapter 7 of our textbook, which covers exponential and logarithmic functions. The first several sections of the chapter will be devoted to learning more about exponential functions, and then once we're comfortable with those functions, we'll move into the logarithmic functions. So this first video is just going to be defining what an exponential function is and talking a little bit about various exponential models. So an exponential function is just going to be any function that can be written in this form: y equals a times b to the x power. So this is a new type of function because our independent variable x is now the exponent. We haven't seen that so far. We've talked about polynomial functions, various power functions where our independent variable was raised to a power, but this is the first time where our variable itself is the power. You'll notice that I've written a few restrictions over here to the right. One restriction that we put on our exponential function is that a cannot be equal to 0. So of course a is this value right here. And the reason a can't be equal to 0 is because if it was, then the entire thing would be wiped out, because 0 times b to the x power would just be 0. So that wouldn't be very exciting. We also require that b be some positive value. It doesn't necessarily have to be an integer, but it just has to be some real number greater than 0. And we'll talk a little bit about why that is in the next video. Our other requirement is that b not be equal to 1. So if b was equal to 1, you would just be raising 1 to the x power, but we know that 1 to any power is just 1. So again, we restrict b from being 0, or b from being 1, because that would not give us anything very interesting to discuss. So let's talk just briefly about what the graph of an exponential function would look like. There are two basic types of exponential functions. We can be talking about exponential growth or exponential decay. Any function that models exponential growth will look a bit like this. And there are some important features of this exponential growth function. Of course, you can probably see why it's called growth, because as x continues to increase, our y values rapidly increase as well. So we know that is, you've probably heard of it referred to as exponential growth. Another thing to notice is that the x-axis acts as what we call an asymptote over here to the left of our function. And this is actually the first function we've really talked about that's had an asymptote. An asymptote is simply a boundary line for our function. So our exponential function, again this is y equals ab to the x, our exponential function can get closer and closer to this value where our y value would equal 0, but it can never actually cross that boundary line. So we also have another type of exponential function, and that's called exponential decay. And that function will look like this. Oops, should actually. Oh, that was just as bad. Let me try it one more time. There we go. So exponential decay, you can probably tell that this is just a reflection of exponential growth. Again, the form of our function is still y equals a times b to the x power, and we still have an asymptote. It's still our x-axis, but now instead of being a boundary for the left side of our function, the x-axis acts as a boundary for the right side of our function. So let's just briefly talk about what determines whether an exponential function will model growth or decay. We're going to go into a little bit more detail in the next video, but this is just an initial summary. So remember that for any exponential model that you have, whether it's growth or decay, your general form of the equation is always going to be y equals a times b to the x power. Now, if you have exponential growth, that's going to mean that a is greater than 0, and your b value will be greater than 1. If you have exponential decay, you have, again, an a value that's greater than 0. That hasn't changed. But what has changed is that your b value is going to be between 0 and 1. So this is the defining characteristic, whether b is greater than 1 or whether it is between 0 and 1. And that determines whether you are looking at a situation that models exponential growth or exponential decay.